Welcome back, Play Basic Coders. Just updating the Function Finder tool, and I was thinking about adding a code comparison tool that would compare two blocks of code. Initially, I just thought, it's probably a bit complicated from what the tool does, and then after thinking about it a little bit, I realised that if you compare two blocks of code together. In this case, we're just comparing the function, so we don't really know the context they're used within. So they might have references to structures or other arrays or call other who knows what they're calling. We don't actually need to trace through the code and look at what they're doing directly. We can just do a couple of simple things, and that will give us a good indication of whether it's the same code or not. And so what I come up with is what this function here does is it picks through the parse source section, whatever. We pass it a file type to give it a hint about what kind of code this is. In this case here, we support these formats: Play Basic, Blitz Basic, Dark Basic, AGK Basic, and PHP. Because the rest of the tool supports that anyway. It really just nominates whether the language has things like the remark keyword or the rem start, rem end keywords or not, or uses a semicolon for a comment, or is it an end of line character, that sort of stuff. So what we're actually doing is, for every character, every possible ASCII character, we're attributing what to do with it. So we just scan through. We've either got an add to output, an ignore. This thing's a quote. The different types of quotes languages can have. Generally, the double quote symbols, but other ones have a few variations there. Is it a single character that's representing a single line remark? So we need to remove those. Or it's a rem block. Other options here are just whether we have a two-stage request. So if we see a letter like an R character, is that followed by an E character? So are we looking to find a remark keyword or a rem start keyword? And that's pretty much the whole thing. So what it does is it works on the assumption that two bits of code that are the same code, even though they might have been restructured a little bit. So we ignore things that are in comments, because comments can be changed between different revisions. We ignore white space, and we convert text into lower case. And once we do that, we can pretty much compare blocks of code to each other as just two strings. So if I run it, it'll show us a test case. Saying up here they match, and the test case just gives you this long bit of ASCII. It's just the same blob of code from two different locations. And you'll see how they match character for character. Now we didn't need to phrase this to understand what the code is doing. We're just making that assumption. If they're the same language, they're the same leftover text, they're the same. If a variable name has changed or a function name has changed, they're no longer the same. So even though the function might be the same behavioral, but you might have refactored and changed a variable name from I to index or something, then it ceases to be an equivalent. So the actual code in this case is these two text files here, 1 and 2. Now, things like literal strings are kept in the same case. So if I did change this to hello world in this particular code block here, and that one there is hello world uppercase, it will no longer match. They don't match. And we can see that here in the actual side-by-side text. So they're no longer matching. So I think this will be actually good enough for my general purposes. The approach is very simple. If we look through the actual code here, this is the whole mapping routine. It's a bit messy because I've got it to support, I need to support a few different languages, and they have slight variations in what they do. So I'm using a table to do this, an array really, and switching some things on or off, as you can see here. But generally, we've got this actions character map, and these are defaulting to 0 when that array is created, and then we're setting some of these lower characters here from 0 to 32. They're really just white space characters. They shouldn't really be in your ASCII. Things like tab and space code and end of line stuff. Here I've reinforced these as being ignored as well. Whereas before I was leaving them in there actually. You put like an add character in here, for example. That would keep character 10 but remove character 13. So when we print them in the debug window here, we get something that looks a lot more like text, but I wanted them removed because it's possible that you might have inserted a few lines between things at some other point, and then that would mean the comparison is no longer valid. That would break the comparison, even though the code itself is the same. So if you went to your function, your code here, say, and just put enters in like that. I'll change that text back to what it was too, by the way. Now the strings match. Save both documents. Hit run. So the spacing and layout of that other one are different. Hello world. When we include the carriage returns, they no longer match, even though they are the same thing. Right? The actual code that's doing this is the same thing, so we won't want to ignore those. Our line feed characters, and they match again. We're not outputting this text to do anything with it. We just want to do a comparison with our best guess, pretty much. This seems to be a pretty good way of doing it. As for how it works, we attribute each character to one of these actions. Whether we add it to the output, ignore it, or is it the start of a quote, and we just block through. So this is all set up here, which characters we want to do what with. In all of the languages we're looking at, character 34, the double quotes, this one here, they're string literals. So we're just going, that's every time we see that thing there, we're going to tell it to hunt down the closing character of that and then skip over the characters in the middle. That's all we need to do that, by the way. For things like variable names and functions and those kind of things, we don't really care what they are. If they're different, and it will fail. We don't care what they're actually called. We just want to make sure that when we force them to be lowercase, so we can do a comparison against the two alternate versions of the source code. Semicolon's a single line, the tilde character's a single line in some dialects. Here we've got a 2-character approach. We've got this thing here as an action of check the next character, and the next character table has what to do if it's these two things. So if we have a // it's a remark, single line remark. Skip the rest of that line. If it's a / character, it's the start of a block, so we find the end of that block. Skip over the text inside it, so we can just remove those from the output code. What the comments say are irrelevant to what the code does. Do we want remarks? Yes or no? We only want the remarks supported if we're looking at basic files, not PHP, or other dialects I might add later on. And a table to force upper and lower case. So the actual loop is this: we grab a character, we use the mid, not the mid dollars, to grab an ASCII character from the string at a position. We use that character as to what action to perform. If this is a check next character, it's a bit messy here. We do a bit of logic in here to check the next character and then see if it's one of these special case basic isms. Is it the remark keyword or the rem star keyword? Bit ugly that, it's got to piece together. But the main actions are at the bottom here. We've got a character code to add this character code out to the output. Ignore does nothing. Quote looks for the end of the quote block. Remark just looks for the end of the line. And the end of the rem block looks for the end of these rem blocks here. And that's all the behavior in it. Apologies for the fire truck in the background. I'm pretty happy with the way this works. And this is flexible enough that we can support a few different dialects within the same kind of structure just by changing the way this initial table is set up, this array is set up actually. But if you're looking for a method, to do code comparisons, that could be a way of doing it for you. Originally I was thinking about writing Alexa and phrasing the whole document, which is pretty much what this code already does. This already has like a minimal Alexa to do particular, that'll run through and find the function declarations within certain kinds of languages. Again, these handful of languages that we were talking about before, whether it's Play Basic, Blitz Basic, Dark Basic, AppGameKit. Writing a phrase is a bit of work, and even though I could reuse some of the code, reuse most of the code that's already here actually, this routine here is it's picking through, looking for the function names. It's not actually tokenizing. It's not building a tokenized version of the source. To do our comparison, we would need to have like a token. Well, I think we would anyway, like a tokenized version of the source, and then run through and compare the tokens to each other, and then abort when they're not the same, or give some feedback to the user about this variable name here is different, or this or that has changed, or whatever. Which seems beyond the scope of the tool. Anyway, that'll do us for now, and I'll put this up later. I'll split this away into its own little project, so if you need to compare code at some point, you can use this. Give it a go. Maybe it'll work for you, maybe it won't. Anyway, thanks for listening. I'll see you next time. Bye.